Bangkok. So before we start, we have a short video from Supabase themselves. And while the video are playing, please feel free to grab some food and enjoy while you're watching the video.
Hi everyone, welcome to the Supabase Community Meetup. I'm Ant, I'm one of the co-founders of Supabase, and it's just so cool to see everyone in these crazy places, just so many countries and cities now getting involved in these community-hosted meetups, and just a huge thank you to the hosts. If you haven't seen your host already today, just make sure to thank them for doing all the hard work. Getting everyone together, getting the venue, sorting out the snacks. These guys just do an incredible job. So big thank you to the hosts. One of the most important things about any meetup, and the Supabase community meetups included, is just getting to know the people around you. You know, these people are likely your future co-founders, colleagues, friends, partners. There's a long list of people who've met at a tech meetup and gone on to build huge companies together. And I think the Supabase meetups are no different. You know, you're all people who are either trying to figure out what Supabase is, or maybe you're already using Supabase to build something cool, either as a side project or inside of a larger company. And I think the more that we all support each other in figuring out how to use these various bits, giving advice, just the stronger we'll all be together as a community. So definitely encourage you to turn to the person next to you and get to know them if you don't know them already, and you know, try and make this a regular thing. Meet up with these people more often, because they're all probably at the same point of their tech journey as you are, and you can all learn from each other. And if you want to get involved in open source and contributing to Supabase, there's lots of ways to do it. There's a bunch of good first issues in all of our repos, and even just helping translate the READMEs into different languages is just a huge help. And it's something that we're not capable of doing. Translating the docs to, you know, over 100 different languages just isn't possible without the support of you guys. So thank you for the people who've done it already, and it's just an easy way to get involved if you want to.
Hey everyone, I'm Koppel, the CEO and one of the co-founders of Supabase. It's really great to see you here again today. If this is your second time, if it's your first time, welcome, and hopefully you have a great night. These meetups seem like they're growing really fast, so thank you very much for turning up. They really mean a big part of what Supabase is. The community really is everything. Hopefully you can tell that from both and my interactions with the community. As much as possible, we try to be there with you and for you whenever you're building. And thank you very much for turning up, even if just showing up today is a really important piece of our launch weeks. Would really love to keep up with all the meetups. So while you're there, please make sure that you take a photo, take lots of photos, hopefully, and just tweet them at us and tweet them to the community. Let everyone know that you've got the best meetup, hopefully, and we'll see who comes out on top in terms of good vibes. So I thought I'd give you a small demo of one of the things that we're launching, and this is a headline feature. Hopefully by the time you're doing your meetup, this will already be launched. This is Postgres.new, and it's an experimental service that we're launching with the Electric SQL team, and they've done something very cool. They've taken Postgres and they've made it embeddable. It's using WASM. You can actually embed it inside your browser, so you can use it in your applications. Now, what we've done is tried to reimagine what we could do with this, and we've paired it up with some AI, so you can do some very neat things. You're at a meetup right now, so let's say that we want to build a meetup.com alternative. So let's see how it goes. Meetup.com alternative. And this should go ahead and scaffold up our entire application for us. It's suggesting here that we have some users, maybe a group, some events, some RSVPs. It's going to execute these and create the tables. Then it's going to suggest that we can store some data inside it. And there you go. We've got a full application scaffolded up based on one single prompt. This is pretty cool because we can take these migrations now and apply them to any Postgres database, or we can keep going. It says, would you like to add some sample data? Let's just say yes. And it's going to seed this. And the nice thing about this is once we've got the seed data, we can actually build some charts. And let's say, oh, it's still going. So we'll just give it a second. And there you go. Because we've got a few RSVPs, give me a chart of number of respondents to each event. And hopefully, if the demo gods are willing, this is going to write some SQL for us, and then it'll give us a chart. So you can actually use this to do a lot of data analysis, which is kind of cool. Okay, so we've got two respondents to each one, which is pretty good. This is good because if you've now scaffolded this entire application up, you can either come here, copy it into your other database, you can download it, and then you can use it inside your application, or we're working on the ability to publish this and use it as a read-only database. And the idea is that these are super small, so you'll be able to publish lots and lots of them, hopefully at some point to your Supabase storage, and then consume them directly from Supabase storage.
So thank you for attending today. Thank you for the host for putting this together. And also a huge thank you to Yuri and Amy on the Supabase team who helped put together some of these community meetups. And they do a lot of hard work behind the scenes to make this stuff happen. So thanks to everyone involved, and hopefully see you in person at the next one.
Okay, and with that, we can officially start the meetup. So before we start, I'll go through the agendas for today. We are already past the intro and announcement, and the first talk session, which I saw a lot of people are excited about, is the Supabase vs. Firebase by Poom and Tobias. And the next session will be the Supabase real-world production by Igor. And the next one would be the custom Postgres checkpointer using LangGraph by Williams. And the last talk of the day, it will be the self-host Supabase and direct admin by Pornpat. And after the talks from our speakers, we will have an open mic talks where anyone is free to come up on the stage and showcase their projects or open source or anything they're working on. And we will also have some cool swags from Supabase to give away as well. And after that, we also have some little games prepared, so make sure to stay through all the talks and participate in the game to get the exclusive swags from Supabase. Okay, so before we start, we would like to thank you, our sponsors that make this meetup possible. Thank you, Supabase, for sponsoring this event, which include the food, the drinks, and the swag. And okay. And thank you, Agoda, for hosting the venue that we are in today. And thank you, the Dev2 Asia and HubQL for hosting this event. So when you press the get the ticket on the guild, you might find that you have entered the Dev2 Asia community. So I encourage you to follow this community, as there will be more events coming up in the future. Okay, so before we start, let's check your Supabase level, like where you're standing now, like if you have used Supabase before. So who think your Supabase level is here? You can raise your hands. Okay. What about this one? I'm not sure what I'm doing. Okay. And what about this one? Super user. Anyone can ask them about it. Oh. Okay, so regardless of what level you may be right now, I hope you will get some new knowledge and experience from the talks today and level up, or get to know Supabase better by tonight. Okay, so it's time for the talk. I would like to welcome on the stage Poom and Tobias for the first talk, Firebase vs. Supabase.
Hello.
Hello, hello, hello.
Hey, yeah, thank you everyone for showing up today. It's a pleasure to be here, and I hope we can teach you a bit about Supabase today. And we thought maybe it's a great idea to compare Supabase to Firebase because Thailand seems to be a Firebase country. So
Yeah.
maybe we will try to change that.
I want to check this Firebase user. Who is the Firebase user? Can you show of hands? Okay. Seems like a lot more than Supabase.
Okay, we will try. So we set it up a little bit like a battle and try to keep it fun, but also very short to give you like a high-level overview of the features and compare them. And we'll have time for questions. So happy to answer any questions you have. You might get a chance to get a T-shirt, a Supabase T-shirt. Sorry, not a Firebase T-shirt. Yeah, but let's get started.
Yeah.
First round, we're all engineers, round 0, right? We start at 0, so introduction, and I think Poom gonna go first.
Yeah, I'm representing Firebase today. So the round 0 for me, just want to introduce for in case anyone never used Firebase before. So can be the next slide. So Firebase is the ecosystem of a NoSQL from the Google Cloud. Next. Yeah, just want to show how the Firebase ecosystem is. So they can do many things just from the storage, database, and to the analytics. You can analytics your app inside of the Firebase. And there are many things. It's all in one kit for a NoSQL database. And next slides. So the main key point of the Firebase for me is that they are integrated with the Google Cloud system. If you are come from the Google Cloud, it's like a no-brainer for you to just pick a Firebase for your main app. Not just your main app, but it's maybe the easier choice for you if your existing infrastructure already on Google Cloud. You can migrate and integrate it into the main system. And a part of Firebase, their cloud function is the glue of every system. So when you are managing your data with Firebase, you can use the cloud function as the main logic to glue for your system from many systems from Firebase to the cloud server from Google Cloud. Yeah, next slide, please. Okay, and yeah, there are many. The ecosystem from Firebase is very big. You can have the extensions from that's just one-click install. You can just integrate it with your Firebase when the event trigger will execute one of these functions, and you can have the one off the shelf. And they also have the Gemini support, not the Gemini support. There are many Vertex and GenKit is a new one, and the Gemini for Firebase. You can use Gemini inside of Firebase more easily. Yeah, and just to mention the Firebase is when you have the traditional backend service, most of the time when you have the backend, you will have the server, and you will build the API to call the database. And once you have the Firebase, it's just not eliminate, but make your life easier. You don't have to build the backend API all the time. You can just use the client app to call it from SDK and connect with Firebase more easily. You can do a CRUD more simple, and that can reduce the task for you to build a backend. And the one key point of Firebase is the real-time feature. You can build a real-time subscription when the database updates. All of your apps, all your client apps can be updated without having to refresh the page or reload the app. And also when someone updates, it can be all synced. Yeah, just to summarize the Firebase into main 3 points for me, I think the 1 point is the real-time feature. And the second one is event-driven. So when you update the database, it will trigger the cloud function. You can listen to the event and subscribe to the event more easily. And the NoSQL, the main feature of that is it's built for read optimized. You can, if you want to have the read performance, it's like a key feature value that could make your app very fast. So, and moving on to the Supabase.
Okay, thank you, Poom. Nice try. Let's see what Supabase has to offer. So Supabase, they claim themselves as an open source alternative to Firebase. So you can already hear there's probably some overlap with the feature set of Firebase, and that's actually the case. So Firebase itself offers a database, also the same for Postgres. It's on top of Postgres database, right? And all the features are implemented normally within the Postgres database. So they are either extensions or maybe built on top as APIs. So there's features like authentication, there's APIs, there's edge functions, and we will dive a bit deeper into the feature set later on. So. And a key feature, I think, for Supabase, if you ask someone or if you ask me, you can be really fast. So you can impress your CEO. Maybe you're a small startup and you want to ship fast. Maybe Supabase is a good choice because you can be faster because you get a lot of features out of the box and you can impress whoever is your boss, right? So it's very helpful. Next, please. Okay. Supabase itself is Docker-based. It's basically exposing several APIs for different services and different features that we're going to go through in the talk later on. They use Kong, and then Kong will route to different services that are running in Docker. So they're different containers, and they're all based on Postgres, connecting to the database in Postgres. Supabase is open source. I think that's the main difference also to Firebase. It's a fully open source. Everything that Supabase does is open source. Their website, things they do, the games they do, the meetups they do, everything is open source, so you can check it out. You can go to the Supabase organization and GitHub, and you can take a look. And I talked with Ty today. He told me if you're stuck with Supabase, maybe you just read the code, right? It's sometimes quite useful to find out and actually get some help. You can just read the code yourself and maybe find a way to improve it or find a fix. Okay, next. Okay, Supabase works with several frameworks, not only JavaScript frameworks, but also other frameworks, Flutter, for example, and many other. So you can use Supabase and directly use their SDKs to connect and use it. They have a thriving community. You can see they have over 1,000 contributors. So there's a lot of people contributing every single day to the repository. So it's really community-driven development. And they have a program called Super Squad. So maybe you want to consider joining. Have a look at their website and go to Super Squad. Maybe you're going to be first-time contributor or be part of the events that they do. So a chance for you to be part of this community. Okay, next round. Round one. So the next round is going to be about data modeling. We're going to talk about databases. I'll hand it to Poom.
Yeah, we're going to compare it like very briefly for here. So we're going to show you the code and show some screenshot of data model. So database for Firebase is, as we all know, it's not only SQL. So we are doing decide the data structure as the key and value. And so it's mainly a JSON data in the Firebase, but it's more advanced than that. We have a collections and many things that can support the features. Support the filter. So like the main thing here is for the real-time database. It's very simple as when you store JSON data, you have a node and nested value and so on. And you can decide how you want to structure data in the simple JSON format. And more advanced feature from Firebase, they have file store. And next slide. And the file store is the more advanced. They store data in collections, and you can have like a sub-collection, and you can manage more data in advanced feature. This one is similar to MongoDB in terms of Firestore, so we can do a more complex filter, and you can still have real-time compatibilities on this one. Yeah, and move on to Supabase.
Okay, Supabase. Like I mentioned, it's based on Postgres. If you worked with Postgres before or SQL database, this will be familiar. I believe this is a little small, but left-hand side, they have a dashboard. So whenever you run Supabase, even locally, they will give you a dashboard and a UI. So even no code, let's say you're not into coding, not sure, maybe you are, so you're going to use the UI to actually create a table. You can define the database schema. You can use their dashboard. Or you can use the code, which is based on SQL migrations. So if you ever work with SQL, you probably know you can create tables, you can make changes to your schema, you're going to use migrations. You can use plain SQL, of course, it's just a Postgres, or you use things like Prisma or any other type of library that you like to manage your database or your Postgres migration itself. Okay, and then you made it schema, then you have to explain it, right? So normally you end up with the SQL schema that is normally based on maybe foreign keys and relationships. And this is what also the difference is to maybe If we compare it to Firebase as a NoSQL database, maybe the concept is very different in terms of how you build applications. So this gives you just a small example how your database schema might look like.
Yeah, just to summarize the concept, I think the Supabase comes from the normalization world. So you want the data integrity, so you don't want to duplicate your data. But the other side from Firebase is NoSQL. You have to like sometimes duplicate the data. So read, you want to optimize for read, but for write, you have to write sometimes multiple times. You have to like extra cloud function to manage to write it into multiple places. So that is more flexibility for design data structure, but yeah, it can be limited in query capabilities. So when you want to like do complex query, Supabase can do more on that in the SQL feature. But yeah, if you want to be in key value, you have to be well think of that before you design your structure. Yeah, structure your data models in NoSQL. Yeah, and one thing I want to show that, and maybe some people still use SQL, right? But some of you guys may still store JSON in the SQL. So that's why I think, yeah, sometimes we might mix between two roles. And just want to introducing a new thing. Firebase not only have SQL, but we already have the next slide, please. Yeah, now we Firebase have the SQL feature. So you can use, since Google Cloud have the Cloud SQL, right? So they introduced a new feature as a Firebase Data Connect. So you can connect your Firebase to a Cloud SQL that is a Postgres in the backend, but they build it into the seamless into one platform. So now it's available in the Firebase in the preview mode. So it can be the next slide. This just want to show the overview briefly of the Firebase SQL Data Connect. So you define how you're gonna query your data, and it will turn this one into the schema, the DDL schema automatically, and it will have the type set SDK for you to query your database. It's in terms of like it's similar to GraphQL. Yeah, and that's all.
Okay, round two, CRUD. We have database, so let's do CRUD next, right? Yeah, next, please.
This one from Firebase. I think the both feature from Supabase and Firebase, this feature is mostly the same. So in terms of you don't have to write the API to the backend, and you can just use SDK from client side. You can use just DB collection, and you get CDs, and you get doc the SF, and this one can be done all in the client side. So yeah, it's make it convenient for you to read and write the data to the database in this way. And yeah, and the Firebase, they also provide the UI. So when you have the collection like this, you can use a filter, and you can just try the condition here, and they will provide you the code. And if doesn't have, yeah, they can provide a code snippet for you to try out.
Okay, Supabase, they have the similar approach. They have an SDK in different languages. This is JavaScript, sorry. Left-hand side, you can see read. So it's functional, right? So you might be familiar with something like Prisma or other SDKs or ORMs. They work very similar. So you define your table. You're going to select the fields that you want or columns that you want. And then you have filters. So you can use equals or any other kind of filters that you want. You can use them in the SDK. The same for updates. It's a very similar approach, right? You just, instead of select, you're going to use update function, and you can interact with the database. Again, this is similar to Firebase. You can use it on the client side, or if you have some sort of approach in React, which is popular now, maybe you can also use it directly in React on server components, for example. They also have the managed connection already, so you get like connection pooling, for example, with Postgres, and can make a HTTP connection to your Postgres database. So it's really flexible where you want to use it. So that's the way you can interact with the Supabase database.
Am I seeing the JSON here, the previous slides?
Oh, yeah. Yeah, that was the sneak peek, how to do JSON. So it's nested field here, address and postcode. So we can do JSON in SQL.
Right. Good point. Yeah, so let's talk about compile query. So I have discussed about the SQL capabilities. So when you design data in the structured way, it's more advanced, so you can do like advanced queries. But for Firebase, it's very limited to just like a key value filter. So the one main limitation of Firebase is that you cannot do like a query calculation-based query. So for example, find me a restaurant where rating divided by price greater than 1.5. This is a SQL query. You cannot do that kind of this task in the Firebase. So you want to have the p-compute value so you can query this value in the future. So it's gonna have example in the next slide. So for Firebase, for Supabase, you can do this kind of query in the Supabase, right? But in the Firebase, you have to pre-compute this one, a value ratio, and you can have the filter this one again in the future. So it optimizes for speed, and you can just simplify your queries. You don't have to like manage this one in the client side, but it have to sacrifice the right complexity in the right time. Yeah. And there are many ways to organize your data in the NoSQL. You can be a nested like this, or you can be a flat data, but yeah, you have to think about the composite index as well, because yeah, as we have NoSQL queries, we have no relation. You have to think about how you're gonna index your key and how you're gonna make the key sortable and filterable. I think. Yeah, Firebase also have the feature where you can create a composite key on your dashboard. Yeah, move on to authentication. Okay, Firebase, I think people may all know that Firebase is very simple to do authentication. They have been well known for a while. They have Google, sign in with Google is the most common one. Once you sign in, you're gonna see like a list of users here in the UI dashboard. So you can like have the user ID, and when people sign in, you can have the metadata of that user as well. And yeah, the code is very simple. You can have the sign in with and provider, and you can just sign in and sign out in that way from the front end.
Okay, let's look at Supabase authentication. I think it's very similar to Firebase as well. It's very simple. You can use a function to sign in. You can use different providers, email, password, OTP. You can have MFA, anonymous logins, and one new thing, you can use Firebase authentication in Supabase. Yay! Okay,
Yay.
so
You're
maybe
gonna steal the Firebase customer, right?
yeah, not sure. Okay, next round of authorization. So how do you handle security or access to your data?
All right, I think the Firebase have the strong point on this one. So when you design your data in the JSON, right, you can have they say that common expression language. You can define how user can access this kind of node and in any level that you want. So your data here, the field here, and so it gives you a robust asset management. I will show you in the next slide. So for example, so here, first of all, if you have the data in the user and user ID, you can use the request authentication. It's the same auth that you get from the Firebase authentication. And you can say that user can only read by if the user ID equal to this one. So that means that user can only access this node if they are the owner of this one. So and create as well, you can like have any rule that define in this structure here. So it can be like in any structure that you want. So any field, any nodes and collections. And the next one. So another example, like when you want people to create stories, that one story published equal to true and read. So if is published, you can read. And also if the user ID is the author of this story, user can read as well. Yeah, that's how you can define, and you don't have to worry about the security in the back end, and you can define your security right here. Yeah, and this is a dashboard of how you manage the security of your Firebase. You have version control, and next slide, you can test your logic before you deploy. So you can put the location here, the database path, and you can see if this one can be validated true or false. So yeah, you can test your security logic here.
Okay, Supabase, the recommended way for authorization is row-level security. Maybe you're familiar with this. But what you can do is you can write a function, and in the function you can have some logic in the database. Maybe you have a multi-tenant system. Maybe you have a creator of the owner ID. And then you can use that as a function, and then you can apply a policy. You can see this in the bottom here. You can apply the policy to a table. So based on the policy, you can then handle the authorization. The way to do it is, well, based on action. So it can be read, update, for example. You can inspect the function results. So it's almost like JavaScript, right? So you can also write actually JavaScript in the functions and return the result. You can use custom JWT claims as well, for example, or you can combine it with Postgres roles. So it's quite flexible, but it can also be a bit complicated. And it sits directly in the database, so you have to also think about optimization. So if you use row-level security, think about the performance as well. Okay, next one, round number 5, business logic and functions. Boom.
Okay, so the Firebase, they are event-driven. So when you want to, so for example, user update the data, you may want to have the additional logic to modify the data from this one to move data around to the other node. So that's where the Firebase cloud function comes in. So they eliminate the need for you to build a whole backend monolith system. You can build just a function and you can deploy it in your just function. So yeah, the main key thing that the Firebase function support both JavaScript and Python right now, and they have auto scaling. And yeah, you can also call function directly. Don't have to wait for event trigger. Function can serve as the API endpoint for you as well. Yeah, and for example, when user update, you watch on the value written for user ID. So the whole user JSON value updated, it will be trigger this function. And yeah, it's one from Python and this one from JavaScript. And you can monitor your function in the dashboard, like how many invocations, and you can also open more logs in the Google Cloud log service as well that you can monitor in your Google Cloud in another service.
Okay, Supabase, yes, they also have functions. They call them edge functions. We want it on the edge, of course. One specialty, they are based on Dino, so it's a Dino runtime. This little dinosaur, maybe familiar to you. And yeah, you can write functions for anything. So handling HTTP requests, you can interact with the database using the Supabase SDK, or you can serve a small REST server maybe. So you can use the function for anything that you like. They are quite flexible. Moving on. Round number 6, storage.
This one is very simple for Firebase. You can store any image, text, or any CSV file. So it's the same when you define the rule as the storage. It's the same as you define rule in real-time database. And you can see the metadata of that file, and you can have they also have the extension for you to modify your data from the file written. So first of all, if user upload this file, you can have another extension is out of the box to reduce the file size to be a thumbnail. This one can be done out of the box for you.
Okay, for Supabase, they also have an SDK. You can interact with the storage. It's based on S3, so AWS service. It's based on buckets and files. If you ever work with this, so it's like folders, and then you can put files into the folder. That can be public or private, and they can also be served from a CDN, so you can do some sort of transformation that you combine, for example, with the edge functions. You can do some image transformation as well. Authorization is handled with the JWT, or you handle directly with S3 because they manage the S3 bucket for you. So you can interact also using the S3 client you can see down here. So either use the SDK or you can use directly S3 if you're scared about login. Okay, moving on. Of course, we are all here for AI, right? So next topic.
Oh, okay. Since the Firebase in the Google Cloud ecosystem, they have many things like to keep up the pace with OpenAI and AWS. So they have their own UI system where you can manage the prompt, and they have, just want to show it just only briefly. Next slide, please. Yeah, and you can use the Vertex AI in the Firebase now. So Vertex AI is ML feature for the Google Cloud. You can build a RAG system in the Vertex, and you can do vector search in that, and it can be integrated into Firebase. Yeah, I just want to have this one is just newly launched, the Gen Kit, so you can build the Gen AI into the client side, so they act as a wrapper for you to interact with the AI more quickly. Yeah, and they also have the embedding feature as well. Yeah, that's all.
Okay, AI in Supabase. I would say two things. Number one is vectors. So you can create columns based on PG vector, and then can have an embedding on your column. There's one example in here. And the second one is they have integrations with models that you can use that are already sometimes pre-installed in the edge function. So you can use smaller models directly in the function and can interact. So similar what Poom actually showed, you can switch between the model, and then you can see you can generate an embedding and just store it as part of your normal data schema. You add one more column for your embedding. Okay, we're almost done. Yeah. Round number 8, real time.
I think we can do this one very quickly. So I have mentioned real-time feature many times for Firebase. So this is just to show another dashboard for Firebase. So this is how you store data in the nested JSON values, and this is for Firebase.
Oop, yeah.
Supabase.
Yeah. Yeah, you got me confused. Supabase, okay. Okay, Supabase, there's two ways to do it. First of all, you have channels. Channels is almost similar, the same as a table. And then what you can use is you can either broadcast. So broadcast is you're listening to events in the database, and then you can write logic based on events in the database, or presence, which is more like online presence or presence in a file, things like that you can use. And authorization done through row-level security as well, because all is based on Postgres. So again, also the real-time is based on Postgres. Okay, last one.
Yeah.
Most interesting one, maybe, pricing.
Yeah. I think we can skip this one, SDK. Okay. You want to continue SDK first?
Yeah, let's do SDK. Sorry, wrong headline.
Okay, just to see the SDK for Firebase. So you have JS and Python here. So it's just to show the snippet of the code is very simple to use. For the Python user, you can just hit install and import Firebase admin, and you can manage your data here. Yeah, the same as JavaScript.
Okay, Supabase similar. You have SDKs for the client side that also able to run on the server, for example, and they're normally scoped. So you have authentication storage admin, and you have a CLI to run Supabase locally. So you can interact and run the whole Docker containers from Supabase locally with the CLI.
Pricing. Okay. So since Firebase has two products, real-time database and Firestore, so the most use case for real-time database, they will not charge for read and write. They only charge for the database data store. So it will be like $5 per gigabyte store. So if you don't have many data and the application require read and write heavy, so it be easier for you to use real-time database. But for this one, I think this one people most say that is the go-to choice, the standard choice if you want to use Firebase. And they will charge you for a read and write, document read and write. So the free tier is at 20K write per day and 50K read per day. But the pricing also very cheap. This are the free tier. And next slide. This one is for so it's the only $0.3 per 100,000 documents. So it's don't really concern very much. So we have a saying that if you Firebase price expensive, that means your app is successful. So you don't have to worry about the price upfront that much. So the cost scale up from the usage of your app. Yeah.
Okay, let's see. Supabase pricing. So there's the cloud pricing. Of course, you can use their cloud offering. They have a free tier, which is quite generous. It's based on monthly users and database space, and also your file storage. So each different function will have different limits that you have to watch out for. I think you have to be watching out for mostly those that are more usage-based. So if we talk about network, if we talk about database storage, you will have to calculate yourself how much you use. You have to observe it. You have to be careful about this. But you can also self-host. Maybe you can run it for free, of course. You can run it locally, or you run it on a small VPS, for example. Of course, it will be much cheaper than the cloud version, but then you have to manage it yourself. So this is the cloud pricing. I think it's maybe, let's say, similar to Firebase in terms of the pricing approach, but it scales as well with your network request or how much storage you have in your database. So make sure you check it before. Okay, seems like we're at the end. Well, who's the winner? Any opinions? Okay.
Questions?
I like your opinion, yeah. Well, you had a Supabase meetup, right? So, I don't know. Let's see, who's the winner? Okay, yeah.
It depends, yeah.
It depends, yeah.
All right.
So let's take a look one more time.
You can go first.
Okay, I'll go first. This is a TLDR, right? If you like open source, yeah, you may like Supabase. If you like self-hosting and tinkering with systems, yeah, Supabase is your bet. If you like it very cheap to start with, yes, Supabase is also a good choice. If you like memes or hype topics, yes, Supabase is for you. They have very good documentation, for real. I would say this is one of the best documentations you can find. And amazing community, you're right here, right? So I think community is great for Supabase. If you have further questions when to choose Supabase, you can come talk to me. Let's see about Firebase.
Yeah, just a quick summary. So if your main infrastructure from Google Cloud, it's the no-brainer for you to pick Firebase over Supabase. And they have a great feature. So you can have the user up to 10,000 monthly active user without having to reach the feature limit. So their feature is very high. So and if you are favor NoSQL over SQL, this is for you as well. And real-time capabilities. So yeah, it's very fast for you to update in real time. And DevX also great, the same as Supabase. They have CLI, SDK, and you can use Google Cloud CLI as well. So it can be integrated when can be easily deployed. And the last one, Vertex AI. So it have the very strong feature on the AI infrastructure that they want to have the platform that can handle many more AI feature in the future. Yeah. All right, and this here is the reference for you to check out the Supabase and Firebase. And that's all for the talk of the comparison. So just want to give a bit introduce about ourselves. So we haven't introduced about who we are. And yeah, for me, I'm from the data scale. We are a SQL analyzer. We help you reverse engineering data models. So if you have lots of SQL queries, you don't know what your data models are, you don't know the metadata from your queries, we can help automate that from the SQL queries to be in our platform, and we will analyze it, auto-generated diagram for you. And this is a shareable spread where your team can share the SQL query and everything together.
Cool. Yeah, thank you, Poom. Check out Datascale. I'm co-founder at HubQL. We are building an alternative to Postman. If you don't like Postman or annoyed about Postman, please come talk to me. Our API client works with different JavaScript frameworks, including Elysia. Maybe that's the one you like. We're looking for feedback. Please have a look at hubql.com or come talk to me. Happy to have a chat, also about Supabase, of course. And I think that's all. So thank you.
Thank you so much. Thank you. Question?
Okay, thank you, Tobias and Poom, for the first talk. So let's keep it going. For the second talk will be the Supabase Supabase real world production example by Igor. Please give him a round of applause.
Thank you so much, everyone. I'm really happy to be here. And today, I would like to talk about how I use Supabase in a real-world project, in something that we're not going to be talking about the theory. Instead, we're going to be talking about practice. And I've been a full-stack developer, working mostly on CRMs and AI systems for UK and Israel. And I also contribute to open source a lot. For example, there is a front-end library that is quite popular on GitHub. It has 27,000 stars on GitHub and more than 6 million downloads each month. And you can find me in the list of the top contributors. So a few months ago, I decided to switch completely to bootstrapping my own project. I do believe that every developer should try to, at least once in a lifetime, to build his own project, because it allows to see the bigger picture, allows you to see beyond the code, to understand better business needs. And I do believe that Supabase is a really great platform for that, because it can basically replace a team of, I don't know, like backend engineers, DevOps engineers, some kind of database engineers, so you can have everything in one platform and run project just by your own. And in this talk, I'm going to talk about the project so you get the context, and then we switch to Supabase features that I find very useful, and I do believe that you will find them useful too. So just to get you the basic idea, currently it is database Supabase dashboard that shows that it has like 10,000 database requests per day, and it has around 6,000 monthly active users. And so you can understand that is a project that is being used by real users. And let's talk about the project first, very briefly. Like, do you know that like 60% of information that we get gets forgotten in an hour? And in 1 week, we get only like 10% of information remains. This rule was discovered by German scientist Hermann Ebbinghaus. And actually, it's quite good, because like we don't need to keep everything that happened to us in our brain. But in case you study a language or music theory or history, you would like information that you already learned to persist in your brain. So to achieve that, you need to repeat the information. And you don't have to repeat information every day. Instead, you can use the spaced repetition approach. For example, you can repeat information on the first day, then on the third day, then on the sixth day, then 25, and so on. So the idea is that you don't need to spend a lot of time repeating information. So you can spend less time, but still effectively memorize everything. And this is what the application I built based on. So simple example. You study English language and you want to remember the phrase "get ahead." So you add a card with this information, and if you answer it correctly, then the app automatically schedules all this word to repeat in 1 day, in 3 days, in 6 days, and so on. But if you fail to repeat, you don't remember, then the intervals are shorter. And then you get smart notifications. So all of it is built using Supabase. And how it all started. First, you need to create a lot of tables, and Supabase provides the most, let's say, user-friendly way to scaffold the database schema. You just use graphical interface to create all of your tables. For example, in my case, I have tables with users. Each user has many decks. A deck is like a group of cards. Then each deck has a lot of cards, and each card has a lot of reviews. So the same card can be reviewed multiple times. by the same user or by another one. And once you finish, you are ready to basically to export it into a real database that is available to the internet. So you just created something on the internet, and then Supabase allows you to convert it to a database that you can use in your code that is publicly available. And how to use it? So you have a basic SDK. I'm going to show examples in JavaScript, but you can use any language you want. And here we just need to access Supabase. We specify the table, then the operation if you want to query something or create a new record. So we specify all the fields, and then we specify what to select. Really nice feature that I enjoy is that Supabase allows you to generate all of your types in code. So basically, you don't have to transfer manually all of the tables, all of the fields to your code. Instead, you run one Supabase command, and you get all of the structure in your code. So in my case, for like an application that has a lot of users, Supabase generates me around 2,000 lines of codes, and it keeps them automatically updated. So let's say I decided to remove some field or rename some field. Once I've done this in the database, I can just run the command, and then these fields get removed from this schema, and thanks to TypeScript, it can point me to the part of code where these fields were used, and you get TypeScript compilation error. So until you fix all those issues, you won't be able to compile your project. And I believe it's very nice since it allows you to iterate faster. It allows you to do less bugs in production. So this feature I use a lot. One of the decisive way for me to choose something like Supabase over like something like Firebase is the idea is that I can write my own SQL query, and the SQL relational data is already optimized for all the, let's say, queries, all the combinations of data that you may want to use. The data is already stored in that way that you can run some analytical queries, and they're going to be like, it's very easy to implement. So for that, you can go to Supabase dashboard and then select SQL editor. And for example, write a SQL query that groups all the users by the language. So, and here is going to be the result. You can see the amount of users and then the percentage. It's something like that PostgreSQL allows to do. It's called window function, and you can use it for advanced analytical queries. It is something that I really miss in NoSQL database, for example. Moreover, you can, of course, use AI to generate query for you in case you think like, okay, why should I bother myself doing that? Let's AI do the job. So here I show how to do that. So I ask AI, show me the number of active users for the last month. And I specify that active is someone who has logged in within the current month. So, and the AI assistant automatically provided me the correct SQL query. And the real killer feature for me is that Supabase actually knows all of your structure. So it really can create correct queries based on your data because it knows everything about all of your database. And you may be wondering, how am I going to use it in the code? So you can ask it like to turn it into PostgreSQL function. Now you see that the AI used the same function, but it is now wrapped in an expression that turns it into a function. And the function is called like get active users last month. It automatically provided all the types. So it returns integer as a result. And once it is available, you can call it in your code. So you just refer to supabase.rpc, then you specify the name of the function. And again, because Supabase generates all of the types for you, here you not only have tables, but you also have functions. So all the functions like function signature or the correct return type, everything is going to be perfectly typed for TypeScript, and it's really nice. So I also use Supabase to store files. For example, if I decide to study Thai, this is how I study Thai, by the way, I can create a file with voice that says Sawadee Krap in Thai. And after the record is created using OpenAI, I can store it in a database and in the Supabase. So I just use storage, specify bucket ID, which is like a folder for files, then I specify a file name, the actual file, and that's enough. Then you get the URL, which you can attach to this card, which is like, in my case, the card was Sawadee Krap, so I can attach this voice and store it in Supabase. And the final step is how to optimize database. The database optimization is kind of a broad topic, and I'm only going to cover indexes because it's a lot to cover. And when we think about how to optimize database, we need to apply basic patterns that we use in real life. For example, let's say we have a book. And we would like to find the word apple. There is somewhere word apple. But we know that if this book is alphabetically sorted from A to Z, the word apple should be somewhere in the very beginning. This way you can narrow down the search and save the time. So this is how all these indexes work in the database. In this query, I would like to get all the cards created by specific user. So the apple here is the user ID. So we need to create an index for this field and for this query. And Supabase allows us to do that. So in the dashboard, you can go to the indexes tab, and then you specify the deck and the column which you would like to be indexed. You might be wondering, why can't Supabase or PostgreSQL create all the indexes by itself? The issue is that creating index has some performance penalties. So it simplifies reading, so the reading is faster. But when you create a lot of indexes, the writing becomes slower because let's say you have a table with 10 fields, and then you insert one record with 10 indexes, and then when you create this record, you need to create 10 indexes. So it slows down the insert while speeding up the read. So that's why you need to fully control it. To figure out which field requires an index, there is a PostgreSQL extension that is built inside Supabase, and you can run your query that you have. It may be as complex as you wish, and then it shows you which fields requires an index in this specific query. Or instead of using CLI, you can go to the indexes dashboard and see, for example, most time-consuming queries, most frequent, and those that have slowest execution. So, and this way, it provides you the list of indexes that needs to be created that internally use this index advisor tool. So, as a summary, we learned how to create database structure via user interface instead of CLI, how to automatically generate TypeScript, so you don't need to manually transfer all the fields from your database to your code, how to write your own SQL for queries, and how to use AI to do it for you instead, how to upload files, because Supabase is not only a cloud platform, it's a full stack platform that can replace a team of developers, and how to optimize your database when it gets larger as your project grows. So thank you so much for listening to me. And in case you're interested in the project, so there is QR code.
Okay, thank you, Igor. That was a great talk for anyone who wants to use Supabase in production. So for the next talk we have coming up, so for the next talk, while we're setting up, the next talk is the custom Postgres checkpointer using LangGraph by Williams. So wait for the checkup for a bit, and we will start with the third talk of the night.
Oh, I can do it. Is it this? Okay, perfect. So you're gonna have to like scroll with like shit. There we go. So you're gonna have to like either click on here or but it's better to just scroll a little bit. Yeah, because there's yeah. Perfect. Yeah. Scroll perfect. Hello, guys. Perfect. So yeah, today I'll be talking about custom PostgreSQL checkpointer using LangGraph. It's a bit of a mouthful, but I'll try to go ahead and break it down into pieces so that you guys can kind of understand how to save data in AI application. So we can go to the next. So my name is Will. I'm a founder at Reactor. So we basically help companies build custom AI workflows in Southeast Asia and also in the US. So currently we have about 2 customers here in Southeast Asia, 1 in the UK. And yeah, I'll tell you a little bit more about deploying your own app, building your own application, especially in production using AI a little bit later. But we'll get to talk a little bit about how LangChain works first. Before I start, has anybody used LangChain in production? Use it, just testing or LangChain? No? Never? No one? Okay, great, perfect. Okay, let's go to the next. Okay, so I think in the first talk they used a specific they used an SDK from OpenAI just to basically call the LLM and then go ahead and then they have a specific prompt, they have the LLM, and then they have the output. So the difference between just using the SDK and using LangChain is the following: you have different types of components that you can use, like tools. For example, you can use tools that are pre-built, like searching the web. You can use tools to figure out if you want to find out the latest weather, or you can use custom tools for calculators. I'll get into the specific details of what type of tools that you can use in production, but you can also use things like RAG for retrieving information. And then also you have the ability to use your chat history when you're interacting with the large language, when you're interacting with your LLM app. So for example, a lot of the times when you're using the actual SDK, you can't typically save your memory. So LangChain has an ability for you to go ahead and save your memory and retrieve information from it. Okay. And has anybody here used LangGraph before? No? Okay, obviously if you haven't used LangChain, you can use LangGraph. Perfect. And then go to the next slide. Okay, cool. So what is LangGraph? So LangGraph was actually built by LangChain, the team at LangChain, and it's based on Prego, which was built by Google. Originally, Prego was built for re-rank. So you usually, when you're re-ranking sites and you're batching requests, so it was built to build like a graph database so you can retrieve information and you can pass information very quickly. And so how LangGraph works is you basically have your graph, you have your node, your main node. This is just as an example. And then you have your tools. So you can search, for example, you can search hotels. You can find the best prices in case of, if you're an employee at Agoda, you'll probably know this. And you can confirm your hotel choice and then send a payment link. And then you have your state. So I guess most of you use JavaScript, right? Okay, great. You guys use React? Great. Okay, state management, great. That's what it is, your state. And so what you can do is you can save your messages, append it, and then also have your hotel choice and your booking history right in there. So if we just scroll down. Okay, so for example, for the travel agents that we're building at the moment, one of the requirements for it is that we want to find the best prices and we want to be able to book your travel agent right directly into your app. So a lot of the times when you're prompting ChatGPT, under the hood, it's actually using a lot of different things, like architectures that you might not be familiar with. We'll get into details about the architecture that you can use when you build like AI apps a little bit later, but this specific architecture is called a supervisor architecture. So essentially you have your question, it invokes a travel node, and then you have your router, which is your conditional node. So it runs a sentiment analysis on whether or not this is actually a question regarding finding hotels. And if it does, if it is, then it moves on to the next node, and then it goes ahead and invokes a search hotel. And then that invokes find the best prices. And then we have an interrupt. So an interrupt is when the user actually makes the choice whether or not they want to choose that hotel 1, hotel 2, or hotel 4, whichever hotels that they want. And then that's when once the user has chosen that, then we can confirm the hotel choice, and then we update the state directly. And then we then use a conditional router to update the actual choice, and then we can send a payment link, which is another tool. So you can think of your tool sets, and then you have your travel agent, which is the actual node that are connected to it. So your large language model has basically helpers that it can basically retrieve or look for to help it out. So I think the main difference is when you're building out your standard application, like at Agoda, you're building out your search system, your like an application that we saw previously, it's all crude, right? So create, read, update, delete. This is a bit different because you're actually giving power to the large language model to make the decision to retrieve a tool or use a tool that it needs. So it's a bit of a shift of how you're thinking. It's in terms of like thinking, if you're thinking of deterministic and imperative programming, where you have conditions and those conditions are set by you, but actually over here you have the sets of rules, and the LLM has to make a decision to use those tools, whether or not to use those tools. So, and then we can scroll down a little bit. I don't know if you guys can see this. Is it possible to click it? It's so small. You could probably click it, I think. Okay, yeah, so here's how sort of it works. So you basically have your state right up top, your check pointer, which we'll get into a little bit later, which is your Postgres saver. And then right after that, you initialize your state, and you have your travel agent. This is actually where you control the state. And typically inside of that, you would have different things like your tools, and then also your invocation for the graph. I don't have the picture there, but if you guys want to talk to me later about it, I'll be happy to show you the code and everything. And this is where you're actually doing the invocation. This is Python, so sorry if you're a JavaScript developer, but Python is much better. Whoa. It's easier. Come on. It's much easier and it's performant. Okay, so anyway, this is one singular endpoint that you can invoke, and then it would find the best prices and everything. So if you, yep, and you can zoom out. Okay, so let's get into what is a check pointer. So essentially, a check pointer is somewhere where you can store states in a graph. And the difference between saving data, let's say in a standard database, like I mentioned, is you're doing at a basic level crude, right? For your check pointer, it's a bit different, where you have a connection, which is like your PostgreSQL URL. It could be something that you're using for, like, let's say on Supabase, and you have the URL. And then you have your concurrency, which is your pipeline. So the concurrency pipeline is where is basically where it sets up the actual database where it creates the tables. And then if it's enabled, this is the actual part that's a bit different than the crude apps. Is it batches most of the commands from SQL, like put, tuple, list, and then also writes. So it's slightly different, where every single invocation with your large language model or your chain will go ahead and batch certain requests together, and I'll show you how that works. If you go down, perfect. Okay, so now going back to our example, we have a travel agent node. So I think if you scroll just a little bit up, oh shit, I moved that. So this one, this is actually the question. And then over here, if you remember what I mentioned about check pointer, every check pointer has a thread, and that thread is then saved. So this you can think of as like your messages saved, your message history with your agent state. This is where it's saved. And then, so anytime you're invoking a question, let's say you want to search for a booking somewhere, right? It will get the current version of the graph state. So it would run a batch for a.get. And if you zoom out, then you would have your conditional node, whether or not it's searching for hotels. And then once you get to the user picking the actual hotel, which is hotel 1, this is where we're batching operations like a.get and a.put, where you have to get the actual current version of the state. And then you then update that the hotel choice is hotel 1. And then this is where you go ahead and you update the state, and then you eventually go ahead and the user approves it, and then you get your answer directly to the user. So let's say if you're using an SDK from OpenAI or Vertex, building an application just like this might be a bit tough, just because you don't have the control flow when you're using one singular SDK. So LangChain just allows you to gives you the ability to go ahead and architect your apps in a way where you have a human in a loop workflow. Okay, and yeah, so this is how check pointer in Postgres internally are saved. So you have your thread ID again, like I mentioned, and each thread represents a version of the state. And actually, one thing that I forgot to mention was, if let's say you're on version 3 of the graph state, every thread has a parent.ts, parent_ts, which reference the previous state of the parent and child, and then a timestamp which isn't in there. But yeah, okay, we can move. Okay, so let me take you through a real-world example. We're working with Salary Hero at the moment. So they have an issue where they're growing about 20% every month per company that they're working with, and they have maybe about 1,000 plus employees that are coming in and interacting with the app, and they need a lot of help. Meaning, like, they need information about loans, they need to retrieve information about whether or not they can take out a loan this month or the next month, and they're getting about, let's say, 800 requests per day. And they only have 5 customer support, and they're only able to reply about 300 messages per day. So they were constrained in that environment. So they try to go to different vendors, but they really couldn't build like a custom solution, because a lot of their data was dispersed everywhere. They had data on Excel, data on Google Sheets, pretty much everywhere. So basically, we came in and we first what we do is we build out a graph model just like this, just to kind of represent like the different state of the flow. This is part of it. I'm not going to show everything, but you can think of the user coming in with their question, with sentiment analysis. Before I actually explain that, the one part of the issue that they had is that their users are online, so we need to identify who the user is. So one thing is what they did manually was they interacted with the customer directly and then try to figure out who it is, look up in the database who it is, okay, which company is it, okay, which is it priority one, okay, and then they went ahead and replied to the user. So basically we basically erased all of the steps from the human that's doing that. And the first thing that we're doing is we're greeting the user. After greeting the user, we're updating the state that the greet is true. After doing that, then we're verifying the user. This is where the large language model is then invoking authentication link so that the user can log in. Once the user has logged in, we saved it in a state, and then we reroute them based on priority. So it's rerouted to customer support large language model that's able to then basically just give information to the user. One of the things, once they're routed over here, I'm not sure if you guys are familiar with the term called crews. So basically you have a master agent. If you go right up top, I think. Oh, okay. So you determine what question it is, and then you have a master agent, and that master agent is then able to then give it, basically pass that information, pass it to the right agent. So company policy, general info, getting a loan, delaying payments, and then that master agent has tools. If you guys remember before about tools, those tools have different types of use cases. So tools, they retrieve information from Google, they retrieve information from Sheets. So they do a lot of customization to then reply to the user. Like, for example, delay payments. So they get an influx of delay payments that's coming in. What we do is we notice, okay, there's a delay payment. We then trigger a tool that then sends an email to the customer support team like, hey, there's about 800 users that are asking for that have a delayed payment, and so you need to basically look at that. So yeah, this is the different ways you can kind of architect it. If you go down a little bit, you might have to exit out of the thing. Yeah, so just to kind of give you an explanation of how you build these kinds of applications, if you go on langchain.com, you can kind of take a look. But once you get to LangGraph, it might get a little bit complex. So I would recommend just going through the documentation thoroughly to understand. But the very first part that I mentioned, when this is the use case for Salary Hero, the company we're working with, is we greet the user first. This is a singular LLM with no tools, just greeting the user. The second architecture is a basic supervisor agent, which has a supervisor and tools that it can use to basically talk to the user and verifying who the user is. And then you have crews. And those crews, you could think of, I don't know, if you're a teacher and you have different types of helpers that are there. One is changing the diapers of the students, and the other is actually teaching the students and assisting the students. The teacher can invoke different tools, different people that she has in her tool set to retrieve information or give information. So this is the same things when you have hierarchical crew teams. But in that case, that would actually be the principal doing that. And this is a good paper to read. If you've never built these kinds of system before, you're not going to understand it. I didn't understand shit. I just put it on ChatGPT and explained this. And then, but it's great. It's honestly, it gives you a perspective on how you can build these multi-agent systems. A lot of anytime I say anything about I'm building a customer support agent, oh wow, this must be easy. But the hardest part is the fact that like information is dispersed depending on the organization, and building something custom is what they're looking for. Okay, thank you. Yeah, again, React Thor. So we're on LinkedIn. These are my email if you want to reach out. If you want to talk a little bit more about what I've been mentioning during this talk, great. If you want me to showcase some examples of applications that I'm building currently with companies, great. I'll do that for you. And if you want to talk anytime, I'm here. All right. Thank you.
Thank you, Williams. And now for the last talk of tonight, it will be the self-host Supabase and direct admin by Khun Pornpat. And after the talks from our speaker, the stage will be open for anyone who wants to showcase their current project or open source contribution. So you can prepare yourself and come up and share your ideas with other people and get some exclusive swags from Supabase. We will also have some games after all the talks are done and the after party at the groove below. So please do stay if you're available tonight. So let's give a round of applause for Pornpat with the last talk. Some technical difficulties. If you want seconds for the pizza or the drinks, please feel free to grab some more. Okay, so everything's ready. Please give a round of applause again for the talk.
Hello, everyone. I'm Pornpat from DevForward, like the software engineer. Sorry for technical. Okay, next slide. Okay, usually, right, if you want to make like mobile application or desktop application, you like, okay, you have that node, right? In this case, right, it's like real project. So in this case, I use Flutter. So the second, you have to think about backend, right? You have to make some API, right? So Supabase is maybe this answer, right? So yeah, you like prepare to use this one. Yeah, the expectation is like you like have like you would like to request something via API, right, from the database. And but in this case, like you have the legacy one. I mean the legacy system, like a report system. Next slide. Yeah, this one. This one is like a traditional module, right? Something like that. Like someone in company make it for a long time, and it's like still useful, something like that. So in this case, right, this module is already exist, but the new one is not yet, right? So I would like to use the Firebase. Oh, sorry, use Supabase. Yeah, Supabase in this case. Sorry. Yeah. In this case, yeah. So so some people think like you can use in this architecture, right? You mean if you want the for example master data or something, you request via the first API, right? And if you want to do some report or get some how to say the report file, right? You call the second API, right? You can do this, but for the authentication privilege or something like that is like you have to control about this. In this case, I try to merge them together. Like this one already run on the leg admin. Is like a existing system. So my solution is like merge two things together and like set them like seamless working, something like that. This is the point. So the next slide. Okay, this one is like came to like this picture. So for mobile application or desktop application or whatever like application, right? So you can get the master data or another things via Supabase, and also you can how to say make the add function and then call add function via Supabase also. And between this, you can how to say use the Supabase feature like JWT authentication, right? As you know, in the how to say the previous talk, right? And also you can keep the legacy system how to say behind the scene, something like that. So to do this, we will set up a little bit. The first one we have already how to say, a server for the leg admin already. So the two things we have to do is like the first one install Docker into the leg admin server, and also you use the Docker Compose for install the Supabase, right? It's easy if you follow the step on the website, something like that. The next up. Yeah, you have to do two things. Okay, this one like I copy from the Supabase document, so you just follow this one. The first one is just go to your leg admin server, I mean your VM server, then you clone the repo of the Supabase. The second, you go to the Docker folder, you copy the environment file, and do something, follow the document suggestion, for example, like a private key or something like that. And the last two things are just Docker Compose pull and like turn the Docker up. Okay, next. From this point, you will get like everything like that Supabase can do. We are how to say this, how to say follow this API like dashboard, right? You can access via UIP and port 8000. You can access the how to say the dashboard, right? And another API, for example, REST API for connect like database, authentication, storage, write time, and also the last one is like function. If you write the add function and put into the how to say Supabase volume, right? You can call, I mean the local function via Supabase API also. Okay, and this one is the how to say the leg admin came to help because the leg admin can control how to say the config file, right? Because this one is already exist, so I use the leg admin to direct to how to say modify the Nginx. Yeah, that connect between Supabase API and the leg admin API. So this one is like a script, right? But like It's really simple. Like you just see the two things, right? So the first thing you just like map the location of each API of Supabase, and then you forward everything to Kong, right? Kong is here. It's like 8,000 port, right? So you do this, right? So it means you can call everything from the Supabase API, right? Already. But this one is like specially, I mean the legacy one. You just like remapping a bit. Yeah. The next. Okay. So the big picture is here, right? So usually the admin they can control this one is very legacy one, like but very easy if you want to make like a sub website or subsystem, right? It's like very traditional one, right? To say very traditional way you can like do with a lot of like traditional one as a web hosting, but this one is like it's like the new one, right? That we connect previously. Okay. Now you can like connect Supabase via the how to say via the domain name like this, because like in the basically Supabase like provide only the IP address, right? You can access via IP address, but when you config in this way, you can connect Supabase via the domain, because the legal will manage about the domain, DNS, and HTTPS or something like that, and also like forward everything to Supabase containers, something like that. So you can access, and then you can see the dashboard here. And next, so this one is a function, because you want to call the report generator, right? It's like a PDF file, but the PDF file should be behind the Supabase API, right? So this one, we write like small script, right, to receive the request via Supabase, right, and then pass to how to say the legacy system like this, right? So this one is like you call to the legacy one normally, and then you pass maybe authorize header or something like that to legacy one, and then if the legacy respond not how to say like 200, next slideครับ okay. You just like pass everything like back as a response. So in this way you can request the PDF file via database via Supabase API also, like everything look like via Supabase. You cannot see like API behind the scene like that. Okay, and this one is like an application or mobile application that like on how to say display on the mobile or application, right? Yeah, employee use, and then this one is like report. If you like how to say call the API for mobile application, you will get the PDF file, like, and then you don't need to care about the logic here because of like legacy system, something like that. Yeah, you just like pass to like ID or information through it. Yeah, this. Thank you.
Okay, thank you. Thank you, every speakers, and thank you, everyone, for listening. Now it's time for the open stage. Anyone wants to come up and share their projects for a cool T-shirt? You want to demo the T-shirt? Yeah, very cool T-shirt, especially for this lunch week. Anyone wants to share? Anyone? Okay. Okay, then we. We still have some time. You can change your mind. Anyone wants to share the project? Allow. Huh? while we're preparing for the next activity, we are closing the live stream. And yeah, thank you everyone at home who is watching. And if anyone wants to like watch the playback again, you can do so at the Facebook Creator Garden.